So sometimes trying to evaluate a certain kind of function by direct substitution yields the result 0 over 0. And when that's the case, there are other tactics that we have in order to rationalize those kinds of functions. And the third kind of tactic we're going to take involves radicals. Namely, we're going to rationalize the numerator, if that's the case. Now, let me illustrate why we might need to rationalize in order to evaluate a similar kind of function using our property about our two equivalent functions. In this case, substituting in x equals 0 does yield the result that square root of 0 plus 2 minus the square root of 2 divided by 0 in direct substitution yields 0 over 0. Right? When you end up with 0 over 0, that means that you probably have some other way of doing it. We're just not going to say it doesn't exist because we know, in fact, it might. So what we need to do is rewrite the function. So the tactic is called rationalizing the numerator denominator, and we rationalize the numerator or denominator by multiplying by the conjugate of the numerator. So we have the square root of x plus 2 minus the square root of 2 over x. And we look at the numerator, and we have two radicals. So our conjugate is going to be the square root of x plus 2 plus the square root of 2. And we multiply that quantity into both the numerator and denominator of the fraction. Now, if you recall, when we were rationalizing the denominator of certain fractions, we did the same thing, except we looked for the conjugate of the denominator. It has the specific result that if we take square root of x plus 2 times square root of x plus 2, the radical goes away, and we're left with x plus 2. If we take square root of x plus 2 times the square root of x square root of 2 and negative square root of 2 times the square root of x plus 2, we're going to end up with no middle term, and we would be subtracting from it the square root of 2 times the square root of 2. In other words, the radicals go away. That was our aim. Leave that denominator in this factored form. So we get the square root of x plus 2 plus the square root of 2 as a quantity times x. And you'll notice what happens next. Plus 2 minus 2, that goes away. And we're left with x over x times square root of x plus 2 over the plus square root of 2. Canceling common factors gives us square root of x plus 2 plus the square root of 2. We now have an equivalent fraction to the one above, and so if we evaluated the limit as x approached 0 of this expression, 1 divided by the square root of x plus 2 plus the square root of 2, we note that we're going to get 1 divided by 2 times the square root of 2. And now I'll rationalize my denominator again by multiplying by the square root of 2 over the square root of 2, giving me the square root of 2 divided by 4. So we have one more example along these lines. Let me just run through it with you. We have the limit as x approaches 2 of the square root of x, 6 minus x minus 2, which is outside of the radical, divided by x minus 2. What do? Well, substituting in 2 obviously reveals 0 over 0. By direct substitution, we're going to rewrite this fraction by multiplying by the conjugate of the numerator. So square root of 6 minus x plus 2 would have to be multiplied by our present numerator, the square root of 6 minus x minus 2. But whatever we do to the numerator, we do to the denominator. So we're going to have square root of 6 minus x plus 2 times the quantity x minus 2. Don't FOIL in the denominator. Just leave it in factored form. Where we will multiply things together is in the numerator, and in the numerator we're going to get 6 minus x minus 4. all divided by x minus 2 times the square root of 6 minus x plus 2. Simplifying a little bit more gives us 2 minus x divided by the quantity x minus 2 times the square root of 6 minus x plus 2. And you'll notice that 2 minus x looks almost like x minus 2. In fact, the two factors are only different by a factor of -1. And so if we rewrite this, this is like saying -1 divided by our quantity, square root of 6 minus x plus 2. And so when we evaluate this limit as x approaches 2 of -1 divided by the square root of 6 minus x plus 2, we can do it by direct substitution. The numerator becomes -1. The denominator becomes the square root of 6 minus 2, which is 4. That's 2 plus 2, and we get our result of -1/4. A little bit more complicated, but not terrible once you learn how to do it, and you'll notice sort of the pattern that happened in both cases.